Let's start it. Let's begin. Good morning, everyone. How are you all feeling today? All good? You still sick, Sonia? No? You okay? So today what we will do is we will cover 2 lectures. Very short lectures, eh? We will not go through all the slides. We will just discuss the main points of the lectures. So today's lecture is on data acquisition, visual and digital image interpretation. We will learn about GIS, GPS, how its concepts and applications in forestry, data acquisition, data processing, storage, and also the dissemination of GIS, raster, and vector data. GIS stands for Geographical Information Systems. It originated, according to Cowan, 1989, it originated, or first recorded use of a GIS is by a French cartographer called Louis Alexander. Okay, the first cartographer was Louis Alexander. Cool. Okay, how did Louis Alexander first use cartography? By overlaying positions of troops to demonstrate military movement during the American Revolution. So what he did is he sent out reconnaissance soldiers. So what these guys do, they go spy around and report back. Okay, these guys are located here, these guys are located here. He pinpoints it on a transparent plastic paper and then takes that transparent plastic, puts it on top of a map, and then he can locate where the troops and the enemy are. So that was his first use of cartography and GIS. So basic definition, geographical information system. Geographical, anything that pertains to geography, geographical pertains to geography. And when we talk about geography, it is the study of land, earth. Is it also the study of water and water bodies? Yes, study of water, locations, study of formation of lands, geography. Eh? How land masses are formed, how topography is formed, how and where things are located, contours, elevations, these are all geography. These are all studies of geography. Now, when we talk about geographical information system, we have the geography, which is the land that we move around. And then you have an information system where all these type of information that you see, like right now you see, I'm looking at the rugby field, I'm looking at a mosque opposite the campus. All this geographical information is stored inside a software or inside a system where you can retrieve any sort of information. Okay, right now we are looking at it physically, yeah? With our naked eyes, we are looking at it physically. We don't know any information, any other information about it. But the information system, what it does is it gets coordinates, every other geographical information about that location or the formation of that land. It takes it and stores it in a systematical order. Okay, so a geographical information system, it just takes information about geographical coordinates, geographical land masses, and geographical points and stores it inside a system. It can be a computer-based system, which is your GIS software. It can be a hard copy system, which is a map. A map is also part of a GIS. Geographic Information System, a hard copy map. So GIS may be defined as a combination of human and technical resources together with a set of procedures which produces information to support decision makers. Okay, so what you can, the benefits of GIS, cartography, and the informations about the land masses, formation of land topography. The advantages of GIS is that you can take everything from outside, put it on top of your table, and then plan out what you need to do. You don't need to go to the physical ground. You can do it virtually, or you can do it on your desktop. That is the benefits of GIS. And then we have GPS. Remember, GIS and GPS. So GIS is the system where you can collect data, and a system where you can store data and you can use data. GPS is a geographical or global positioning system. The defining word there is positioning. Positioning. So one is a geographical information system and the other one is a global positioning system. So the key word is positioning. This system can also be a map, can be a computer-based, or can be a technological handheld device, such as your smartphone. What it does, it positions your location on top of planet Earth. So what or how do global positioning systems work? We have planet Earth that is orbiting, and then around planet Earth, we have positioning satellites, right? These satellites that are orbiting the Earth, right? We have planet Earth, and then we have small satellites orbiting in they are orbiting in standard areas around the planet Earth. So what happens when you switch on your GPS or you switch on your smartphone, you switch on your any smart device? What it does, it connects directly to these satellites. And the satellites talk to each other and they say, is this person close to you or is it close to me? Proximity wise, they will look for they will detect the ranging or the transponding from your phone. Okay, when you are switching on your phone or smartwatch, it is transponding signals. When it transponds signals, the closest satellite will catch your location and show you where you are located. Okay, even the bus card that we use, okay, the bus card that we use, when you're tapping your bus card, that yellow machine on the bus, it has a global positioning system. It tells the system or the computer that, okay, this person has boarded on this bus. He is destined to get off in Nakasi. That is also a global positioning system. Okay? The bus card system is a combination of global positioning because it tracks the bus movement, and it's also a combination of GIS, where it's taking information about whoever is boarding and exiting the bus. Okay, so these two are two different concepts. Geographical information system, it stores information where you can use, and global positioning system, it stores information of your location on top of Earth or on planet Earth. How has cartography and surveying evolved over the years? Before we used to use, we normally use surveying compass, right? We used surveying compass. You know, the Sunto compass, the one that we use on the ground. Before we normally use that. But now, after the invention of GPS, global positioning systems, we have moved away from compass, the physical compass. Now we can also use the GPS device. This is a specialized, the image that you can see here is a specialized GPS device. This instrument has a user interface. Okay, so whenever I say user interface, it means this screen. Okay, abbreviation of user interface is UI. Sometimes in your QGIS, you'll notice a warning comes in and says something is wrong with your GUI. It's a graphical user interface. So the GPS device has a interface, and it's a specialized instrument that are used by trekkers, used by forestry, professional foresters, used by anyone who goes out in the field. So what it does, it's a specialized instrument only for locating your position on the ground, and also for collecting the latitude, longitude, the coordinates of your position from the ground and storing it inside the device. This specialized device has a built-in compass. It has a built-in compass. So with the device, you do not need to carry a map. You do not need to carry a compass. You only need to carry a spare battery. This is how surveying and cartography has evolved. Before, in FBS 502, yes, we used set squares, protractor, compass, pencil. We use that to locate our position. Now, when we come to FBS 700, have you noticed that we have never touched a protractor? We have never touched a set square. We're only using the higher technology level of cartography. So this instrument is a specialized cartographical and a positioning device. So how is it applied in forestry? Okay. So number one says that you can use it for aerial spray application. Number two is you can use it for mapping systems, fire control, and harvesting operations. Hands up if you have seen the Ministry of Agriculture drones, the ones that, okay, they are massive drones. They're loaded with 20-liter tanks of mix of chemicals, and it just flies over a field and then sprays. Okay, so how is that applied in aerial spray application? Before that drone actually goes out to fly, a person goes out with a GPS device and then just plots out the starting and the end point of where that drone needs to fly, or the starting, the end point, and the track it needs to follow while spraying. Okay, you pinpoint that on a GPS device, take those coordinates, put it on the system, and then the drone will automatically load those coordinates into its hardware or software, and then once you start up the machine, it will just rise and start spraying. And number two, in mapping systems, before when we were at work, when I started in field work, what I noticed is there was a specialized department of forest surveyors. Before and during a harvesting operation, what they used to do is go out, and you know what we did in FBS 502 in mapping and surveying? They used to go out and locate the bearing and the distance of roads, location of landings, the length of the roads, the direction of the roads. They used to go out and pull tapes and record bearings and then come back and plot it on a piece of paper. That operation normally took them around 3 to 4 days or even a week. Okay, and then what happened is we took a GPS, a global positioning system device, and what we did is we attached a GPS device onto vehicles, onto the company vehicle. So rather than the people going out and surveying the actual area, what happens is while the team is being taken out to the field, the vehicle that is taking them is also collecting those positioning systems. So rather than sending out the people to go and actually get bearings and directions, we just extract the GPS coordinates from those vehicles and we throw it into QGIS or any GIS software, and then it just locates the road for us. Rather than sending 3 or 4 people to find the route and the track of the road, 3 to 4 days, we just send the vehicles. Now, even what we normally do is you can fly drones over the area. It will take a picture, and then that picture will come and georeference it on the map, and then we can locate the routes and landings, and the high points and the low points. Even in fire control, the Fiji pine, they have lookout points, fire lookout points. In all the high places of their pine nests, they have a big tower. So every day someone has to be watching from those big towers. So rather than using that, they can send out a drone every morning, midday, and afternoon. So what the drone can do is just locate if there's a possible fire threat or if there's a small fire happening somewhere. So rather than someone looking out the whole day, you can just send a drone. What the drone can do is detect fire. Even nowadays, we have special thermal imagery systems. So these drones can carry thermal sensors, and it will just detect on the ground where is the high temperature areas. So someone has to go and stand by in that area. Fire control, eh? And then in harvesting operations as well, you can send out drones with global positioning systems before a harvesting starts, during and after a harvesting operation ends. You send out the drone to just detect or monitor how much area is being harvested every day. Okay, so you can do what you can do is send out a drone during the or before harvesting, and then 3 weeks or 4 weeks after harvesting, and then at the end of the harvesting season, you will locate in real time how much is being harvested within a given area. Okay, so GIS and GPS has moved away from needing people to actually be on the ground, and now moving into advanced technology of sending in drones, taking satellite imagery, just using GPS devices, which takes lesser time, has a high resolution, and can give you information that the compass and the tape cannot give you. Okay? But there's a catch, eh? Whenever you are using these machines, remember, they need battery, they need electric packs, electric battery packs. So they normally die over time. And also, whenever a GPS or a GIS system is used, we always need to have ground truthing. Ground truthing is the process where after you send out a drone or use a satellite imagery for remote sensing, you have to send someone to go and ground truth it. Sometimes what happens is in remote sensing, it does not, if you're using a 30-meter resolution image, it will not show you to detail what is going on the ground. It will only show you a small detail. So ground truthing is, let's say, on my remote sensing image, I noticed that someone has logged out near the boundary of my forest through the remote sensing. So what I need to do is actually go on the ground to verify if that is true. That is what you mean ground truthing. That is the process of ground truthing. In land use planning, remember in land use planning, the NDVI that we did last week, right? You guys remember? Okay. Sometimes after you do the process of the analysis of NDVI, you notice that there is a green, dark green image there. And then when you go on the ground, you notice that the forest there has been removed. So what you got from the information from the remote sense image and what you see on the ground is totally different. This is the reason why we need to always conduct ground truthing. Whenever you do a GIS or GPS analysis, always ground truth to verify your information before you send it out for public use. When we talk about data acquisition, for the last 3 weeks, the data that we have been collecting, how many of you can explain where have we been getting our data from? Or describe where have we been getting our data from? It talks about data acquisition and availability of data. For your first practical, how many of you remember your first practical? What was your first practical? What were you supposed to do? Vector layers, eh? Vector layers of what? Of the Loisuva. You were supposed to create a point, a line, and a polygon vector layer of something around the Loisuva. How did you get your information? Okay, we were all sitting in the room. No one had set foot in Loisuva. How did we get information about Loisuva? We use georeference base maps. We use satellite imagery of base maps. So the good thing about that, it is free. We just needed to do install a plugin in QGIS to get us the base maps, and then we can look at, okay, the Mbure was here in this XY coordinate. The road is located here in this XY coordinate, and this is the boundary. That is one form of data acquisition by using what? Base maps, satellite images. That is one form of data acquisition by using base maps. That was practical number one. What was our second practical? Contour, or digital elevation models, right? In our second practical, where did you go and get your information or data from? You went and got it from Open Topography. Was it a paid version or was it a free version? Free version, eh? The digital elevation model or SRTM data that you collected was free of charge. It was a 30-meter resolution spatial image, so it was free. That's the second form of data acquisition. And number three, where did you went and get, what was your practical number three? NDVI. Where did you go and get your information from? USGS. United States Global Services, or Geographical Global Services. This one, contour, you use SRTM for open topography, SRTM mission, open topography. And this one, what did you use? Base maps or satellite images. Okay, in GIS and GPS applications, normally you need to acquire data, because wherever you are sitting and whatever you are going to work with is totally far from like you're not going to be located where you're working, whatever you're working in. For example, the Loisuva, we never even went to the Loisuva, but we got coordinates of the mbure, the road, and the starting point of the road, and the boundary from satellite images. Number 2, we got it from open topography DEM layers. And number 3, we used Landsat imagery. These are some sources of data, GIS remote sensing data. This is what it means by data acquisition. Majority of GIS analysts, they go out into the website, into websites, they go to QLTB, they visit Ministry of Lands and any other sources of data so that they can retrieve data from. So normally in GIS applications and remote sensing, we normally use 1, 2, 3 sources of data to cross-check everything that we are doing. Okay, and data acquisition in remote sensing is not easy. Okay, you remember in practical 2 and practical 3, you need to open accounts. Okay, in GIS and remote sensing, the more specific the data you need and the more spatial resolution that you need, the higher the quality, the more money you will need to spend. That is the general definition of data acquisition, or the basic concept of data acquisition. Okay, this is the main concept. Quality and cost. The higher the quality, the more the cost you need. For example, you may need to acquire georeference topography maps of Fiji. Right now, if I ask you to go and look for topo maps, where will you get them from? Where would you get topographical maps? A topographical map that has already been made. It has all land uses on top of it. It has been georeferenced. If I ask you to go and look for it, where would you go? Any idea? What is the first, well, who is the first stakeholder that comes to your mind? If I ask you to go and look for a topo map, topographical map. Fiji Bureau? Fiji Bureau of Statistics? Nope. They will have, but they do not specialize in GIS and remote sensing. Land Survey, Ministry of Lands, eh? Now, if you go to Ministry of Lands and ask for topographical maps, what will they need from you? They need the title and they need the money from your pocket as well. Okay? The more quality data that you get or need, the more you need to fork out from your pockets. So just understand this. All these free data that you're getting from USGS, Landsat, SRTM, normally what you will get is 30-meter resolution data. 30-meter spatial resolution, you can't use it for specialized planning. You can use it for, let's say, locating areas, for telling the general topography of an area, but you cannot use it for, let's say, stream delineation. Okay? Or you can use it for you can use it for contours, but when you need quality or more detail, you will need to purchase at least 10-meter, 3-meter resolution SRTM data. Last year, our FBS 700 students, they generated their contour maps and the NDVI maps, and then they went to the FNU Open Day. They broadcasted it on the wall. You guys remember their booth? It was Brian, Maria, and the year 3 students. So when they had their GIS and remote sensing booth, there was a gentleman from, I think, Monash or Queensland University. He came and he asked, where did you guys get your data from? Then we said, no, we just got it from Landsat 9 using the USGS website. Then he just turned his back and went. And then after that, I went and asked him, where do you get your data from? And he said, oh, the data that we normally use is 3 meter to 10 meter resolution. And the reason why he asked was he thought that it was a more quality image. But when we said, no, we just got it from the free USGS website, he knew that it was a 30-meter resolution, and then it would be of no use to him. So he just left. Okay. So from that communication, what I realized is that the more detail and quality data you need to spend money as well. He said that we normally use 3-meter resolution, and it normally costs $3,000 for one acquisition. Just for one, remember that one image that you got from Landsat, it may cost you $3,000. So that is the basic relationship. The more quality, the more money you need to fork out. You guys have done digitizing, yes or no? Can you remember if you have done digitizing? Would you remember if you have done digitizing? Map digitizing. You remember in year 1, your assignment? You went, you surveyed it on the ground, using your compass and your tape. You plotted it on a piece of paper, and then what did you do? You scanned or took a picture, and then you georeferenced it on your QGIS. That is digitizing. You've digitized an actual forest survey from the ground, and you've placed it on a map or information system. Now, the way that you did it is you just took a picture of it. Sometimes other people normally use scanning devices. They put it on top of a scanner, because the scanner, what it does, when you close the scanner, it levels your paper and everything is flat. So it's more quality. When you put your piece of paper on your table and you have done something with your piece of paper and you've opened it up, folded it, example, if you folded your piece of map and then you want to digitize it, you put it on the table and take a picture. Remember, after folding, this is how your paper will look like. The shape of your paper will be curved. If you take a picture of that, remember, it's not flat. So quality and quantity is not there as well. Pixel and quality of the pixel and the quantity of the pixel is distorted because your paper is like this. So whenever you want to digitize a map, better use a scanner and then send it to your information system. Attribute and relationship data, these are the tables that you make or generate while you're conducting your point, line, or polygon vector data. You remember when you were in year 1, when you were creating your vector layers, you were naming it. Yes? Did you put names on your vector layers? Did you put information of area? Some of you, Though all those information are called attribute data. So all vector layers come with attribute data. Remember when you stored your layers, when you create layer and when you save layer, wherever you go and save it, there is a SHP file and there are every other different formats that are saved together. You remember that? All those different formats, one is your attribute data, which is your table data. The second is your coordinate data, image data. So when you save one layer, all these attributes are saved together with it. And that is what you call the attribute and relationship data. These are the texts and numbers that you place to a point, a line, or a polygon while you're conducting your vector or raster data. And that is lecture 4. Do we have any questions for lecture 4? No questions? What is the difference between GPS and GIS? GPS and GIS. One is a positioning system and the other one is a information system. So one locates your position and collects your position. The other one is an information system, just collecting information and then placing it on a system, on a software. That's the basic difference between GPS and a GIS system. Lecture 5, Basic Processes and Structure of Spatial Data. We've already discussed this in the last lecture. What is GIS? It's a collection of physical, human work, processing, and presenting data. So components of GIS is one, you need users, people. Number two, you require a software. Number three, you need data. Data meaning not only network data, digital and Vodafone, you need actual data, like vector, raster data. You need procedures to follow, meaning procedures, you have already done your NDVI, now you need to go and ground truth it on the ground. Verification processes, those are procedures. Then you have your hardware, which is your computer, your servers, your workstations, your table, your plotting machine, those are all your hardware devices. And also you need, number 6, mostly important, internet. Your base maps, without internet, you can't collect your base maps from your GIS software. Yes or no? Am I wrong? Without internet, you can't use your base maps, your satellite images, Google images. Try loading your HCM GIS plugin without internet. It will never work. You require internet. Okay, GIS data. GIS data normally works on 2 basic information, and that is spatial and attribute data. Spatial data is X coordinate, Y coordinate. Attribute data is the X and Y coordinate of that tree. The attribute data can be height, diameter, species, location, soil type, root system, tree form, taper function. Those are all attribute data. All the other information that come with the spatial data. How many of you are confused? How many of you are still confused or require a bit more explanation? So example, when we talk about spatial data, let's say Valeria is sitting in LT1. What's the X and Y coordinate or latitude or latitude and longitude position of where Valeria is sitting. Okay. Let's say if I go to Google Earth, and I need spatial data of where Valeria is sitting at this point in time. Valeria, go to your phone. Do you have a phone? Go on your phone and navigate to Google Earth if you have Google Earth or Google Maps. Go to Google Maps. Everyone has Google Maps. On your phone, everyone can do it. On your phones, go to Google Maps. Go to Google Maps, open your Google Map, and try to find your location. Before finding your location, you need to switch on the GPS system on top, on your settings. So let's say Valeria is sitting somewhere here. If this is your soil lab, this is LT1 somewhere here. Let's say Valeria is sitting at this corner. So Valeria's spatial data position is written down here. This is my X and Y coordinates. These are my X and Y coordinates, right? Keep your eyes down here. So this is my X and Y coordinate. That's the X and Y coordinate of this pointer, right? Let's say Valeria is sitting somewhere in this room. Her X coordinate or latitude is 18 degrees, 3 minutes and 1 seconds, 98 milliseconds south, and 178 degrees, 31 minutes, 49 seconds east. That's her latitude and longitude. That is your spatial data, where you are sitting, located at this point in time. Assumed, we are assuming this, because that is generally where LT1 is located. That is your spatial data. What is Valeria's attribute? You can't get attribute data from spatial data. All of you know Valeria's attribute. What is her height? Estimate, what is her height? 2.1 meters? 7 foot? 7 feet? 5 foot, right? Okay, one attribute is height. 5 foot something. What is her weight? 65 kgs. Second attribute is weight, 65 kgs. What is she wearing today? Brown shirt, clothing. That's another attribute. What's the color of her bag? What's the color of her bag? Black and brown. What kind of haircut does she have? Piala cut, side cut, bob cut, 3 combined. Okay. What is the complexion of her skin? That's the 7th attribute. What is the complexion of her skin? Tan skin. Let's say brown skin. Brown skin. Right. Does she wear specs? Other attributes. Does she have a missing tooth? No. Valeria, do you have a missing tooth? No? Yes. What kind of phone does she have? 10th attribute. 11th attribute. What shoes is she wearing? What type of footwear? Yeah. Sandal, slip on? No, yes. Another attribute. Does she wear any earrings or jewelry? Any jewelry on her fingers or ears? Mama. No? Okay. That's her attribute data. and her spatial data we have there at this point in time. Let's say after 6 p.m., someone calls you and says, Valeria hasn't reached home. After 3 days, someone says, still she hasn't reached home. What type of information will you use to locate Valeria? What type of information? The only information you will use it is at, what's the time now? 10 past 10. She was at that location, and these are all the attributes that we notice with her. Right? And that is what you mean by spatial and attribute data. That is what the police use when they try to locate a missing person. If you know her relatives, then you can put her father's name, mother's name, or phone number. That's another attribute that we forgot to put. And those are all the attribute data that you fill in your enrollment form before you register or admit into a program. Yeah? So that when you don't appear for classes, we call your mother and your father. And that is what you mean by spatial and attribute. Spatial is that, your location, and your attribute is all the other features or other information, other attributes that are linked to the person. So one is qualitative data, which is all those attributes, and quantitative is the latitude and longitude down there. Set. You understand now? Clearer, some more clearer image. And now when you combine spatial and attribute, you have a relational database table. Okay? In FNU Academics Office, they have a database of each and every student that has enrolled, graduated, not yet graduated from this university and college. So they have a relational working database of each and every student and staff. GIS also uses that same type of information. Right now, if you're operating your QGIS, you also have a database behind your point, your line, and your vector layer. You've already covered raster and vector data, yes? You don't need to go back and explain it. Okay. One important information we missed in our last practical is this. You remember when you downloaded the Landsat Band 4 and 5 image? Before you downloaded, it was in your interface, there was the image and there were all other information underneath that image. Okay, all the information there was this. Your cell references, this, all of these information were listed under that image. Okay, if you go back to that Landsat image, you click on it, there were all the other informations. Now, whenever you get data from website or any source, they will give you all this information. Just to show you that this is the quality of your data, and this is the location of that image if you put it on a map. Now, the grid system on planet Earth, the grid system is a system where if there's a reference row and column, for example, in any mapping system, wherever we are sitting in this LT1, there is a reference row and column number, latitude and longitude that locates this actual room itself. Any data that you get from websites or data sources, they also have those information with it. Okay. So before downloading any data, check for the resolution, check for the location, check for the coordinate reference systems. Some of these data, when you acquire them, you need to change the CRS, coordinate reference system, to suit our Fiji coordinate reference system. That's just a point to note, if you are going to use it further. That is lecture 5. Any questions? Any questions? Are there any questions? No? Everyone clear? Let's just check who is joining us on Zoom. Okay. I get so This is your second semester in 700 level, eh? How was your final exam last semester? What type of questions did you get? No more multiple choice and all that. Okay, question number 1. Explain how this person used cartography and remote sensing. How did he use that in the war or in the army? Finding the positions of the troops. First, he sent people to find the positions, and then they called it out to him. He located it on a piece of paper, and then he overlaid it onto his map. Then he was able to plan out what or which type of defense system does he need to send to that. Okay, so that was the first use of remote sensing and cartography by Louis Alexander. How do you use, okay, explain to me one way how GPS, global positioning system, can be used in forestry. Sonia, can you give us how a GPS software or global positioning system can be used in forestry? Application wise. Area, yes. Harvesting areas. By fire control. Any other? Spraying. Okay, all those 3 were listed in our lecture. Any other apart from that? Over harvesting, yes. Climate effects on different forest stands. How would you use GPS? By the location of okay, let's put it in forestry concept, forestry context. So when you are answering question, give me an example in a forestry term. You said locating a point of something that you didn't know. Okay, give that statement in a forestry example. Yovika? Apa makalisi? Geographic position of plots. What kind of plots? Inventory plots, harvesting plots. Remember in our forest biometry? Forest stands, eh? In forest biometry, we had plots in our stand. You can use GPS to locate those plots, and then after every year, just keep going back to that actual location to plot out or to measure the same plots. Georgina, how can you acquire data in GIS? GIS meaning remote sensing as well. What are some sources of data acquisition? Let's make it more simple. What are some of the sources of data acquisition in remote sensing? Any source where you can get data from? Base maps. Who is the provider of base maps? When I ask who is the provider of base maps, what is your answer there? Who is the provider? The provider is the person who is giving you the data, right? So when he said base maps, satellite data, normally where do you access those satellite data from? Google Earth. So the provider is Google Earth. For your SRTM data, who was the provider of that SRTM data? Open Topography website. Open Topography website. Where did Open Topography get their data from? That SRTM data, they got it from a satellite. What was the name of that satellite? What was the name of that satellite? No, it was not Landsat. It was END something. The name of the shuttle that went out for the SRTM collection, for that mission. It was a mission. What was the name of that shuttle? N something. And Endeavor. You remember that shuttle? When did it go out to space? 2000 and something, yeah? 6 or 9? 2009. It went out to space in a mission called SRTM. What was the mission called? What is the long form of SRTM? Satellite, radar, transmission, mission, SRTM. Who paid for that mission? NASA. NASA was the person NASA was the organization that sent Endeavor. But who paid for it? Not Elon Musk. American government, Russian government, the Indian government, and all other big governments. Try to read about SRTN. The more you read, the more you will be able to write in your essays, in your final exam. Just read about it. You don't need to cram, just read about it. Okay, those are your providers. Okay, number 3, analyze the relationship between data quality and data cost. What happens if you want high quality data? Number 3. The higher the quality, the more expensive the data will be. Okay, right now we are getting 30-meter SRTM data free of charge, 30 meter. Let's say when we want to come down to 3-meter resolution, we cannot get it from USGS, Lancet. They will not have it. You'll need to buy it from them. Okay. Number 4, provide the various data categories in GIS. Spatial and attribute data. Who is the provider of Ben 5 and Ben 4 imagery, Landsat imagery? Who is your provider? USGS. Where did USGS get their data from? Not Endeavour. It's a different satellite, eh? The name of that satellite is? Me. What was the name of that satellite? Landsat. Okay, lecture 5. What are the components of GIS? There are 6 components of GIS. You come under which component? The first one, which is people. What is the second one? Software is somewhere there. Yes. What is the, okay, let's not go number wise. Just call it out. User or people, software, network, intra and internet, data, and procedures. It's in the lecture, eh? I think like third slide, I think. If you think about it, while we were doing our practicals, right? Those six components were all engaged in practical 1, 2, and 3. Think about it. Who was doing the practical? You, the people. What were you using? QGIS software. Who was your provider? Your data source. The internet, USGS. What was it? Open topography, right? What data did you use? Mosquito data and FNU data, right? What procedure did you use to get your contours? DEM layers, and then you extract. Okay, those were some procedures that you use. What are the categories of GIS data? What are the categories of, there are 2 basic main categories of GIS data? You already said that. Okay, that is 2. Another 2 levels of data in GIS. First practical and second practical. Vector and raster data. Those are the 2 types of categories of data. Analyze the differences between raster and vector data. One is basic. Answer for number 2 is in 3. Eh? What is the difference between raster and vector data? Hmm? Both of them uses coordinates. What is the main difference? One is an image, one is a geo-referenced image, and the other one is a what? One is a generated image using point, line, and polygons. Vector data uses point, lines, and polygons, and those are generated by you. The raster image is just then a picture which has been geo-referenced. That's the basic definitions, eh? Set. Yeah. See you tomorrow. Thanks. Tomorrow night. What night? Tomorrow, then I'll take your attendance.